Hi guys, welcome to another episode of Rock Bottom Airsoft. It's good to see you again. If it's your first time here, then as always, it is good to see you and I hope you're going to stick around. Okay, well, welcome to our weekend video. Those of you following the channel, as you'll already know, I normally look to do a video midweek, normally on a Wednesday, and we also do an upload normally on a Saturday every weekend. And we discuss everything Airsoft related, all things Airsoft, bit of tech, bit of replica reviews, gameplay, you name it, we try and cover it from an affordable point of view and also to help out newer players, and if you're an existing player, maybe give you some information you didn't know, hopefully, and maybe get some information back to me if I don't know it. Okay, well, today's video is our weekend video. We're back in our normal environment, which is great, and what we're going to look at today is the basics of rate of fire when we're looking at an AEG, or an automatic electric gun. This came about because I've had a few people ask me now when I'm at my home site at Tazball Airsoft, and a few times people have said to me, how can I make my rate of fire higher? Now, as many of you out there that are doing teching on your own guns and maybe even know a bit more than me about it, it is a complex field, is getting rate of fire. It's a balancing act. It's like tuning, performance tuning. And with any performance tuning, there are pitfalls and there are elements where we need to take great care. But what we're going to cover today is just the very basics of how to increase the rate of fire of your replica, the items that you should look at to improve your rate of fire, and maybe some of the knock-on effects that'll have. We're not going to go too in depth into the tech inside of the rate of fire, and I'll get into detail about that when we look at each individual component that you want to be looking at for your rate of fire. Now, you might also think, why would I want to increase my rate of fire? And that is a fair point. If you're happy with the performance of your replica, if you're happy with the rate of fire you're getting, then by all means that's great. And there's a lot of replicas I have where I don't even touch them. I'm happy with the way they are. But there are advantages to rate of fire. You might not be looking for an insane rate of fire like you might have seen on some YouTube videos. You might be looking for trigger response. Now, rate of fire and trigger response can go hand in hand, because trigger response is basically how fast your gearbox can cycle. The faster it can cycle one round, the better trigger response you're effectively getting. And obviously, if you have an insanely high rate of fire, the chances are that gearbox can cycle very rapidly. So you also will look at these ideas for increasing trigger response as well in situations where you're going DMR, or if you're in a field where semi-auto is only permitted and you can't use full auto, or indeed any environment where you would be looking for trigger response over full auto. I myself don't use a lot of full auto, but I do like a nice clean crisp trigger response. So let's take a look in here. Let's have a dive into it. Remember, if you do enjoy this series of videos, then as always, do please subscribe to the channel. That way you won't miss any of my uploads, okay? So let's dive straight in anyway. The first part we're going to look at for the basics of rate of fire is your electrical system. We could call this electrical efficiency, but mechanical efficiency can go in hand with electrical efficiency. But basically, we're looking at making our electrical system as efficient as possible, with as least resistance as possible, and putting out as much power to the motor as possible. Because obviously, if your electrical system's on point, then, you know, you're basically going to have a higher rate of fire. You're going to have better performance. If your motor spins faster, then the gearbox is going to cycle faster. As I say, we're not going into the full details of what you do in your gearbox. We're going to have a look at some parts in there as well. But the basic idea of rate of fire for your electrical system is making that motor spin up as quickly as possible, draw as little current as possible so that your battery lasts longer, and also run very efficiently. We don't want it heating up, so we want to keep the heat at a minimum. We want to keep that motor spinning as quick as we can and get as much power to it as quickly as we can. So what can we look at to improve to get that electrical efficiency? Well, if we're after more power and we want it to spin faster, then the first port of call could be these are in no particular order either, guys. You know, that you can do all of these modifications individually, or you can do them all together. There's no particular order of importance on them, or ease of fitment. I'm just going through them in the order that I pick them up off the bits I've got together here. So, first thing that I'm going to draw out here is the mortar. If you want a faster running mortar, then put a more powerful mortar in. This is a Warhead brushless mortar. These ones have the benefit of high torque and high speed. I did a video recently on the differences between mortars and things to look for when picking a mortar. So if you want more information on high torque and high speed mortars, and generally what to look for when buying a mortar, then go back and watch that video. I'll put a link to it in the description if you haven't seen it already. So that's one thing for your electrical system. If your mortar's more powerful, I normally recommend high torque mortars, but if it's more powerful, it's going to turn over the gearbox much more rapidly. So your mortar is one part of the electrical system. And the next thing you could look at is a Mosfet. Now you'll hear all sorts of rumours and stories about Mosfets, and you'll hear things called Mosfets that do way more than just be a Mosfet. A Mosfet is basically just easiest way to explain it is a switch. It replaces the heavy current going through your trigger contacts and sends that current directly to the motor where it's needed. So it's just a signal voltage that runs through your trigger contacts. So for our purposes here, fitting a Mosfet can improve trigger response and rate of fire very slightly, but just because it's going to reduce resistance in your electrical system, because it's using a signal voltage to your trigger contacts, but all the current is going straight down through the motor, least path of resistance, it's going straight to the motor. So it reduces resistance in the system, makes your trigger more responsive. So a Mosfet is well worth having if you are looking at doing an electrical system upgrade. If you have a Mosfet in your replica already, brilliant, you don't need to worry about it. The other good thing about this is as well, I'm hazy on this, but some people will tell you, you'll see on communities and things, that having a fuse creates resistance. Now, that is accurate. A fuse will create resistance, but the resistance should be minimal. However, if you want even less resistance in your electrical system, you can get many Mosfets. Some of the gate Mosfets do come with a thermal fuse, which basically it's fused. You don't need your standard cartridge or blade fuse, so you can replace the fuse and just have the Mosfet because it is fused. But check your Mosfet instructions, because some of them require a fuse before the Mosfet, some of them have a built-in Mosfet, a built-in fuse in the Mosfet. So if you get one that has one of these thermal fuses and has a fuse built in, you can go ahead and delete the inline fuse that's in your electrical system, and that again will reduce some of the electrical resistance that's in the circuit that makes up your electrical system. So another great part is getting rid of the fuse using a Mosfet that has one built in. Next up, you could have a look at your wiring. Thicker gauge wiring offers less resistance. They're normally measured in the American wire gauge, which is AWG. 16 AWG is normally the thickest you can get. I think most replicas tend to come with 18 AWG. Basically, the lower the number, the thicker the gauge of the wiring. But obviously, if you're going to rewire your replica, make sure you can fit that wiring in and that it's not going to cause problems getting chewed up by your motor pinion, and it will physically fit. But that is another way of reducing resistance in your electrical system, is thicker gauge wiring or better quality wiring that's basically more conductive and provides less resistance. So wiring is another part that you can look at for increasing your electrical efficiency. So next up, we've got some bits and bats here to show you, and very simple to do is your battery. Now these are lithium ion batteries, but if you're using LiPo batteries or even NIMH, the theory is the same. Basically, that is a 7.4 volt battery. As you can see, 7.4. And that is an 11.1 volt battery. Now remember, to get higher rate of fire, we want the motor to spin faster so that our gearbox turns over more rapidly. So, pretty much self-explanatory. If you put a more powerful battery in there, it's going to make the motor spin faster. So that'll be one of your easy ways of increasing your rate of fire and trigger response put a more powerful battery in. Wouldn't normally recommend to go above 11.1. Some people do in extreme builds, but we're looking at the basics here. 11.1 volt battery is going to make your motor spin much faster than a 7.4 volt battery. And at the same time, a LiPo battery is going to make your motor spin faster than a NIMH battery, and they're normally smaller as well. So there's advantages to moving up there. NIMH, you normally get 8.4 and 9.6 volt NIMHs. Obviously 9.6 volt is roundabout equivalent to a 7.4 volt LiPo or lithium ion battery, but you will get a slight improvement over NIMH if you move to a 7.4 volt LiPo. So battery, that is a big way of increasing the power to the motor and also making it spin faster. So that'll increase your rate of fire as well. And then the last thing that I'm going to look at in the electrical system is the type of connector that you select. Now these are Amas Dean's connectors. I like the Amas connectors. They're nice, good quality Dean style or T style connectors. These connectors offer a much more solid contact patch between each other than a Mini Tamiya connector does. So if you're on Mini Tamiyas, it is well worth swapping over to Dean's connectors. I also did a video on how to swap to Dean's connectors. So if you haven't seen that video already, I'll put a link to that in the description so you can have a watch of that one. And it'll show you step by step how to swap over your connectors to a Dean's connector. That is an upgrade I well recommend doing for a number of reasons. In this particular instance, you're probably not going to increase your rate of fire that you'd notice, but you're certainly going to reduce the amount of resistance in the circuit with a much better quality connector. But also they can handle higher currents, so as you're moving up the power scale and using bigger motors and bigger batteries, those motors are going to draw more current and your battery is going to be capable of providing that current. Then, you know, your connectors, they will become important because you want them to be able to handle the current load that's going through them. So Dean's connectors, well worth part of your electrical system, especially when you're looking at increasing rate of fire and trigger response. So there we go, electrical system. All those things are going to increase power to your motor, or indeed if you've got a more powerful motor, that's going to increase the power and the ability to turn your gearbox over. So all these items are things that you can do to increase rate of fire from the electrical side of your AEG. I would say that the ones that you'll notice the biggest effect from is putting a bigger battery in, a more powerful motor, and the Mosfet. If you put a Mosfet in and you haven't got one already, you'll probably notice an increased trigger response. Maybe not so much the rate of fire, but you'll certainly notice an increased trigger response, which means you're on the right path. You put a more powerful motor in, I will guarantee you that you will notice the increase in rate of fire. There'll be a noticeable difference and an improvement in trigger response. And finally, if you put a more powerful battery in, like an 11.1 LiPo or lithium ion, you will certainly notice the increase in rate of fire, and you'll also notice an improvement in trigger response. Wiring, connectors, removing fuses, those are all additions. They all help with electrical efficiency, reduce heat, reduce resistance. Resistance causes heat. That's not what we want. We want less resistance, more power, more efficient running system. So that's us done with the electrical system if we're looking at improving rate of fire. So what's next? Well, next we have to have a look at the gearbox itself and things that we can do to increase the rate of fire in the gearbox. So, gearbox, what we're going to have a look at. Well, you can reduce weight. So your piston can have an effect, believe it or not, on your rate of fire. This is a cheap rocket piston. It's been pre-Swiss cheesed, as they call it, which means these holes have been drilled into it, which means that the piston is lighter. Again, I know there's people going to be saying you've got to look at reinforcing the box, doing upgrades to make it stronger, getting your shimming on point, all those kind of things. But we're just looking at the basics here of what increases rate of fire. So, lightening, making things lighter, making the piston return more rapidly will, believe it or not, help with increasing rate of fire. And it also helps with something called PME, but we'll get onto that in a minute. So there you go, piston. That can affect your rate of fire. A lighter piston is easier to basically return. So it's easier for it to be pushed forward by the spring more rapidly. So that helps. Next thing we can look at is the spring. The spring itself can affect your rate of fire, and obviously has a big impact on power. If you go with a lighter spring rather than a heavier spring, it is much easier for the motor to draw that spring back. Because it's easier to draw it back, you're going to get less power, but you're certainly going to get an increase in rate of fire because there's less effort to draw that spring back. However, that is counterproductive when you're looking at going for high rates of fire, because again, we go back to returning the piston as quickly as possible, because that can assist with not getting pre-engagement. A very light spring is going to return the piston more slowly, and then you run the risk of damage. But the spring can certainly have an effect on your rate of fire, but not that you'd possibly notice big time. Next up, I would say to have a look at your lubrication. This is a very cheap way of improving your rate of fire. As well as lubrication, look at shimming. You'll hear a lot of stories about shimming here on YouTube and also on social media, on forums, things like that. And I'll agree that, you know, people are really good at shimming. There's those people out there that can do perfect shimming, and I look at it with envious eyes sometimes because they'll just be silent. But shimming and lubrication go hand in hand, because just like the electrical system, we want to reduce resistance, but this time it's mechanical resistance. The less resistance you have in that gearbox, the more rapidly it can rotate, the more quickly it can cycle, the less effort the motor has to put in to cycle the gearbox, which will have a knock-on effect on trigger response and also rate of fire. So good quality grease is important. You don't want too much. There's lots of things you can do to improve mechanical efficiency in your box. And one of those is good quality lubrication, sparingly used, but enough to prevent damage. At the same time, you want to ensure that your shimming's on point, so it's not too tight. Too loose will actually increase rate of fire in some cases, but you're going to burn stuff out. So you want a happy medium with your shimming. You don't want it too tight, because again, we want to reduce mechanical resistance, which shimming and lubrication is all part of. If you reduce the mechanical friction in there, the mechanical resistance, you're going to get a higher rate of fire. So lubrication and shimming is another thing that's worth looking at. And then last, but definitely not least, the thing that can have the biggest effect on rate of fire is your gears. A set of standard 18:1 gears here. So your gears can certainly affect your rate of fire, and that's because your gears can come in different ratios. Your standard ratios usually tend to be about 18:1. You have various ratios of gears available on the market of varying qualities. I quite like SHS gears. I've built builds with 12:1 gears, and I've built builds with 16:1, 18:1. Basically, the lower the number, the higher the rate of fire is the easiest way to look at it. So if you put, if you've got 18:1 gears and you put 12:1 or 13:1 gears in there, it's going to increase your rate of fire greatly, because that's referring to the number of rotations required to have one drawback of the sector gear. I'm not going to go too much into detail in that, but needless to say, if you're putting in an extreme set of gears, then that's when it becomes very important to look at springs, pistons, and obviously your electrical system as well. You'll need a motor that can pull that extra torque of going for a lower ratio gear set. But we're only looking at the basics of what will affect rate of fire. There are extreme gear sets that you may very well have seen, which will be called DSG, or dual sector gear. Basically what that refers to is this here is your sector, that set of teeth there, that's what pulls the piston back and then when it gets to the empty section, as it were, that's when your piston shoots forward. With a dual sector gear, instead of just having one set of sector gears like this, you'll have two, as the name suggests. And that means every time it rotates a full rotation, it's pulling the piston back twice. So you can get monolithic rates of fire with a dual sector gear. It can end up being quite insane. If you have a look online, I'm sure you'll see videos of people showing off their DSG builds. Me personally, I don't build DSGs. I haven't gone down that particular rabbit hole yet. It's something I've been considering, but there's a lot of work involved in making an effective, smooth running and relatively reliable DSG. So there we go. Them are some of the things you can look at mechanically. There is more to it than that. You can get problems with feeding, stuff like that. So I think what we'll do is now we'll touch on some of the pitfalls that are there with high rates of fire, especially if you're going for extremely high rates of fire. All these items are items that you can do that will increase your rate of fire, from the expensive to the relatively affordable, but they all have one thing in common. If you make your rate of fire too high and the piston is returning before the sector gear has completed its rotation, then the gears are going to strike each other under the force of the piston. And that's what people mean by pre-engagement. And that is why when you start looking at really high rates of fire, you can look at short stroking, which involves removing teeth from the gear. You can also look at stronger springs. A stronger spring will return the piston more rapidly, so you've got less chance of pre-engagement. However, obviously with a stronger spring, you start getting an increase in power, which might put you over your sight limits. So then you've got to look at short stroking to reduce that issue. It can get very complicated, and there is a lot of research to do on high rates of fire. You can get feeding issues with double feeds and things like that, so you end up needing a delayer chip. And there are lots of items you can look into when looking at rates of fire. It's not as clear cut as you'd at first think. However, these are the items that you'd be looking at primarily if you're looking to increase your rate of fire. These are the core things that would affect it. Obviously, you're going to need ancillary backups. The faster your gearbox is cycling, the quicker items are going to wear out. So obviously wear is increased. Reliability will become more of an issue, as with anything, when you tune it up to a higher performance than it was designed. However, that's where it comes to ball bearing, spring guides, radius in your gearbox. There's all sorts of things you can do to increase the strength of the gearbox shell itself, and to increase the strength or the efficiency of the components in there so that they don't wear quite as rapidly. They are going to wear out. It's just how long you can make them last effectively, as with anything mechanical. So that's one of the pitfalls to look at. You're going to wear things out more quickly, and eventually you could have failures. The other side of it is you could have immediate failure if you don't think through what you're going to do. I mean, for example, if you're re-greasing and re-shimming, that's only going to improve the gearbox. And basically, you're not really going to damage anything. You'll get a slight increase in performance, not huge, but you've got a good bedrock for other improvements on performance because it's running more efficiently. The battery. If you put an 11.1 volt battery into a replica that isn't rated at 11.1, then yes, absolutely, it is going to increase the rate of fire and it's going to increase the performance. There is absolutely no doubt in that. It will do that. It's just how long will it last? You might be lucky. People will go on about not putting an 11.1 in a replica that doesn't have a Mosfet. I've put 11.1 volt batteries into replicas without Mosfets, and they've lasted a good few years without having any problems. And it usually hasn't been the trigger contacts that have burned out. It's been something else that's broke. However, be aware that on other cases you might be unlucky. You plug your 11.1 in and it breaks within one game day. So you can have instant failures if you go extreme without any supporting modifications. So be aware of those things. So there we go. That's my take on a few of the items that you can add to your replica, the basics of increasing your rate of fire and knock-on effect, increasing your trigger response. As I say, to you guys out there that have done all this, there are lots more things to consider. There are lots more things you can do to increase trigger response more in depth. But those are the basics. So if it was me and you're relatively new to Airsoft and you're just wanting to up your rate of fire, change your connectors to Deans, because that's well worth doing. It makes your life easier for one. If you're running on a 9.6 NIMH battery, go to a 7.4 volt lithium ion or LiPo. And if you want to, up to an 11.1 volt battery, you'll certainly see an increase in rate of fire there. And stick a new mortar in, a more powerful mortar, you'll certainly notice an increase in rate of fire there. And a Mosfet, because if you haven't got a Mosfet, it's well worth having, especially if you want to run an 11.1 volt Lion or LiPo battery. And then after that, then it's up to yourself how far you want to go on it. If you're going to be opening up the gearbox, re-grease, re-shim, maybe look at your gear ratios, your piston, lightning things, that type of thing. Get that mechanical efficiency up. Okay guys, well I hope you enjoyed that video. I hope you've discovered some things there that are maybe new to you. If you have any questions about any of this, or any questions about Airsoft in general, then drop me a comment below. I'll always respond to a comment. I might not get back to you straight away, but I will always respond. And ultimately, if you've got anything about any of this that you're thinking of doing, let me know about your builds. I know there are some really nice builds knocking about out there where people do some really nice jobs with high rate of fire builds. And ultimately, if you did enjoy the video, please drop a like on it. If you're enjoying my series of videos, then as always, please do subscribe to the channel and you won't miss my uploads. And if you want anything more from myself, you can find Rock Bottom Airsoft on Facebook and Instagram. There's photographs, discussions, that type of thing on there of stuff that I'm up to and what they're up to at my home site at Tazball Airsoft. And if I don't see you on the field at Tazball, thanks very much for watching, and I'll see you in the next one.